Hey everyone, this is Matt Perez, and welcome to the last video of creating our pair of dice and doing a motion simulation on these guys. Before we start, I want to make sure that you guys go to your add-ins menu and make sure that you have SOLIDWORKS motion turned on. If you don't, then you're going to get kind of a limited set of tools when you go in to create a motion study. So by clicking on the motion study tab down here, the top left corner of this is the type of study. Now, if you don't turn on your motion simulation, the only thing you're going to get is animation and I think basic motion. If you want to do a realistic motion analysis, you want to turn on gravity, you want to have realistic interaction between parts, you're going to want to turn on the motion analysis. Alright, the first thing I'm going to do here is I'm going to apply gravity, which is this little apple icon. So you can see over in the right corner of my window I have an arrow showing me which direction gravity is pointing. Now in my case I want it to be in the Y direction, actually negative Y. So I just clicked on Y. You also have the option to give it its own reference based on any of your edges or axes in the assembly that you have. So my gravity is going to be pointing down in the negative Y direction. So now that we have gravity applied, you can see it automatically made our motion simulation or motion analysis 5 seconds long. So if we simply calculate this, we can take a look at what's going to happen here. So let's calculate this, and you can see that those dice dropped really quickly and they dropped through the floor. I'm going to turn this down to quarter speed and go back and just play this from the beginning. You can see they dropped right through the floor. There's no interaction between the parts. So the next thing I want to do is give these guys a contact. So it's going to be a solid body contact. I'm going to grab both of these and my plate, and I'm going to go ahead and say the material is acrylic, and I'm just going to leave all the friction and all the elastic properties the same. We're doing an impact study. So I'm going to go ahead and hit OK. Now we have a contact. I'm going to go ahead and recalculate that. We'll take a look at what happens now. Alright, so now these guys hit the table and they bounce just fine. You can see they're kind of vibrating around a little bit. And that's just a result of how the simulation runs. Now what I mentioned before when I was talking about extruding this plate, based on your simulation properties, the motion study properties, the number of frames per second you have, the 3D contact resolution you have, it's possible that these guys will slip right through that plate. If the contact between these doesn't happen at a certain point, it's possible that the resolution needs to be kicked up, or you can simply make this plate a lot thicker. If we made this plate really thin, even though in real life you drop something on it, it's still a solid object, and it'll bounce off of it, or you know, however the interaction works. In a simulation study, it needs to have a different set of contact resolutions or a different set of parameters in order to simulate and adjust that. Alright, so now we can take a look at this. Both of these guys fell on the number 5. I'm going to play it from the beginning. You can see they kind of bounce around and they both fell on number 5. Again, let's slow this down a little bit more and we'll look at this from the beginning and watch this what's happening. Alright, they bounce around, they really don't do much. In order to change that, I'm going to hop out of this study. Actually, I'm going to go back to the original point, and since we're in the motion study, we're not in the assembly, any moves that we do in here aren't going to affect the model. So I'm simply going to just drag these guys using the move component, and I'm just going to move this guy a little bit higher so they're not at the same height, and hit OK. And let's recalculate the study. Alright, so you can see that time they fell completely through the plate. And let's play it again from the start. Playing it really slow, they fell right through the plate. So what I want to do is I'm going to hop back out of this study. I'm going to edit this feature here. I want to make this plate thicker. So right now it's 0.1. I'm going to make it 1 inch. Actually, let's just go ahead and make it 2 inches. And hit OK. Let's hop back into the motion study. And go ahead and recalculate that and see if that changes anything. Alright, so you can see because I raised that 1 up, the point of impact or the contact was at a different place in the animation. It was all pretty much a game of chance for when I dropped that thing. but you can see that it fell right through the plate. But now I made the plate thicker, the contact is a little bit different. You can see they kind of roll around a little bit. It's still landing on a 5, so I don't know how accurate that's going to be. Let's go back and let's rotate this guy. Let's zoom in on him. Let's do another free drag. Let's drag it so that they kind of fall on each other a little bit. Yeah. Alright, so now let's go ahead and recalculate that. This will definitely get us a different number. Oh, 3 and a 1. So at this point you're probably thinking, what can I really do with this? You replay this, you recalculate it every time, it's going to land on the same thing. Well, you're dropping them in the same exact position, so it's going to simulate and animate it in the same exact orientation. From this point, you can save out the animation. We can save it as an AVI file from the SOLIDWORKS screen. We can kick up the frames per second. We can change the resolution. Let's do HD format. And we could also save it out as photo view. Now, if you guys are going to save this out as a photo view animation, I strongly suggest you save out a series of images rather than the actual animation. You can use any kind of program after the fact, and there are a lot of free ones out there where you can put them back together in the in order in an animation and save it out later. The reason you want to do this is because if any of these single frames fail, when it's actually rendering your animation, it's still rendering a single frame at a time. It just happens to be compressing and putting them together while it's doing it. If anything happens during that time, if the computer glitches, if something happens with one of the renders, you're going to lose everything. With the individuals, you have a better chance of retaining a lot of the information. And when you want to actually look at motion, you want to kick the frame rates up pretty high. I typically go between 20 and 30. So I'm going to do an AVI file, but I'm going to do the SOLIDWORKS screen. I'm not going to actually render this guy. And I'm going to save this off. So I'm going to do full frames, uncompressed. You can see there's a few codecs that I have based on what you guys have installed on your computer. And this way it'll go through every frame. And you saw I did 30 frames per second, so we have 30 frames in a 5-second long animation. So it's got to kick through a lot of different frames, but this will give you a really good result. And obviously, you guys probably wouldn't have a need to save an animation like this out, but hopefully you can see that doing a quick study like this. I mean, drawing the part was relatively quick. Setting up the study was relatively quick. We only had to add gravity. I moved a few things around. I created a solid body contact between both of the die and the plate that we have on the ground, and everything ran fairly quickly. We didn't have any glitches. Obviously now it's slowing down because it's saving out all these different frames, 20, 30 frames per second. But everything was really easy to set up. It was really quick to go through, and really simple. Hopefully you guys saw that it was really simple to go through all these steps. So as always, if you guys have any questions, please email SOLIDWORKS support at mlc-cad.com, and we'll see you next time.